Let's finish the rest of the problem. We're revolving around x equals 2, and again we're starting with those same equations, y equals x squared plus 1 and y equals negative x plus 3. So I've drawn the region. We're going to copy it on the other side. So go about the same distance. And now we're going to have a parabola that comes up, and we'll have the line. And my picture's not perfect, but that's okay. Now let's draw our rectangle. And we'll copy it over into the reflected region. Now we're going to connect them, and this time our elements are parallel to this axis. I don't typically use this. When my two rectangles are facing each other, it's going to be a washer, and when they're parallel to each other, it will be a shell. Now, this is like a can that has been, we're going to split it here because right now we have a cylinder. We have a little circle, it has some thickness to it, and when we cut it and open it up, it will form a rectangle with thickness. So in other words, a rectangular solid. Oh, I forgot to label over here. What is the thickness of this rectangle? It's along the x-axis, so it's delta x. And when I come over here, I can label delta x. How am I going to find the height of this rectangle? Well, that's going to correspond to the top minus the bottom. And again, we want everything to be in x. What is the top curve? The top curve is negative x plus 3 minus the bottom curve, which is x squared plus 1, or we could have just done it all at one time. We do need to simplify it, so we'll have negative x squared minus x plus 2. What is the length of this rectangle? Well, when we take this and we just make a slice here and open it up, so it's going to be kind of like this. Let's go here and then open it up. We get our rectangle. What is the length of this rectangle? It's going to be the circumference of the circle. So we need a radius. It'll end up being 2 pi times that radius. And what is that radius? The radius is going to be the distance from our rectangle to the line that we revolved around. I forgot to also put my little rotation there. So how do we find that? That's going to be the right minus the left. The right is 2, and the left, remember this is a point, x comma y. So it'll be 2 minus x. And we'll put 2 minus x there. Now, for many students, this is a hard thing because of the fact that this rectangle can slide throughout the region. Well, let's take a look and see, does this really make sense and is it correct? Let's assume for a second x is a positive value. Well, if it's over here, let's say a half, when we say 2 minus a half, we'll get 1.5. So in other words, it's a number less than 2. What happens if it's over here and it's, say, negative 1? When we say 2 minus negative 1, we'll get 3. And so this radius can be as small as 2. Actually, no, in this case it'd be small as 1 because that value is 1. And then over here we would have the value of negative 2. So this radius would go upwards of 4. At this point we can set it up. We have the integral from what to what? Well, we're going, again, what is this rectangle sliding throughout the region? We're dealing with our x numbers, so we're going from negative 2 to 1. And we have 2 pi, it's a constant, so we can just leave it out. 2 pi r and then we're going to multiply it by the height. So this part right here gives me this front area. And how do I get my volume? I'm going to take the area of the face times the thickness of it, and that becomes our dx. Now we need to multiply all that stuff out, and we'll get -2 to 1, and that will end up giving us, we'll have an x cubed, and then we'll have a -2x squared and a positive x squared, so a -x squared, and similarly we'll have a -2x and oh, I didn't write this one down right. A -2x, so it would be -4x and then +4. And when you integrate that and go through all the steps, 1/4 x to the 4th minus 1/3 x cubed minus 2x squared plus 4x, your answer should be 45 over 4 times 2 pi, which will give us 45 pi over 2. Now let's look at the next one. Again, for these kind of problems, you should make sure that you can do those and that you're not making any simple errors. You want to practice that so you can do it consistently right. I don't need to move it over. On this time, we're going to be sliding about a line that's to the left of the region. So over here was a line to the right of the region. Now we have to the left. And so we can write that we're revolving around there. And this one will look like that. It's curving away from our line, and we can connect those points. Let's draw a rectangle in our region. We copy it over into the other side, connect them. Could have made it fancy and make that dotted on the back side of it, but that's okay. It's not so important. Now, again, let's label here. This is going to be our delta x. Our radius this time will be from there to there. And that point is x comma y, which represents any point on the curve. When we open this up again, we just have some region that represents it. We have delta x. Our height is found in the exact same way. We've already done that calculation, so we could just write it down. Now we need to say 2 pi times our radius. What is our radius this time? Well, it's going to be x minus -4 or x plus 4. Again, let's check to make sure that is right. What happens when x is a negative number like -1? Well, when we say that -1 minus -4, we get a radius of 3. What happens when it goes to the extreme over here? Or actually, we can just say a half again. 1/2 minus -4 is 4.5. So when the rectangle's to the right of the y-axis, our radius is going to be longer than 4. And when it's to the left of the x-axis or y-axis, it'll be less than 4. So we'll have x plus 4. Look at the similarity between these two. We have -2 to 1, 2 pi times x plus 4 times -x squared minus x plus 2 dx. Can multiply that out as well, and we'll get -x cubed minus 5x squared minus 2x plus 8 dx. And when you find the antiderivative of all that and simplify it, you'll end up with 63 over 4 times 2 pi, which will give us our 63 pi over 2. And that pretty much covers these two plus the previous set. Gives you an example on how to do any of these that are straightforward. We're not using our calculator, and how to set them up. And that's it.